Okay, how about we give a little bit of the landscape of the brain-computer interface industry, the various companies that are doing something in it, and how are we different from that? And where do they sit? Because a lot of times I'll mention Paradromics and they'll say, oh, well, we know Synchron, or we know some other company, or Cognition. Can you give us a little bit of the landscape of them? We respect all of them, but they're not doing the same thing.
So there are a lot of different ways of trying to guess what's going on in the brain. So we can start with the things that you can buy on Amazon. You can buy devices that will sit on the skin and measure electrical activity on your scalp. And what does that measure? Well, it measures whenever the brain is doing, all the neurons are doing something highly correlated. It can pick up things like how focused are you? Are you about to initiate some sort of action? Really kind of coarse signals. If we wanted to put a data rate on it, best case, about 1 bit per second is what you can get from wearables. Now, there are downsides of wearables. One of them is you have to wear them. And so there's a company, Synchron, which actually just raised $200 million that came up with an idea to allow for a brain-computer interface that would be put up through the jugular and into the blood vessels of the brain. Now, the advantage it has over a wearable device is that it's there. It doesn't get in the way. It's more ergonomic, doesn't move around. Disadvantage, of course, is it's something going through your blood vessel. That device has a bit rate of also about 1 bit per second. Now, when you want to start getting more data out of the brain, and that's basically a button press, like once per second. So it's not huge. You don't have to do Paradromics Neuralink stuff, but for some people who are paralyzed, it's still very useful. As you want to start getting closer to the brain, you have to go under the skull. And then there are devices that sit on the surface of the skull, almost like on the surface of the brain, like a blanket, that can measure when tens of thousands of neurons are active at the same time. And that can allow you to do things maybe like control a cursor, kind of okay, but it taps out at around that data rate. If you want to start doing the stuff that I was describing earlier, or even if you want to restore speech or you want really good cursor control, you actually have to get into the layers of the brain, get close to the individual neurons that are the source of the signal, and talk to individual neurons and talk to a lot of them. And so that's what Paradromics and Neuralink do. They record from individual neurons at scale. And
can we talk about the stadium analogy that we use to explain why it's important to be so close in proximity to where you're getting the data from compared to further away, and then using AI to somehow error correct because it's not the same day?
Yeah, definitely. So we can see some microphones in the front row. We have some microphones here. You can see already when I get far away from my microphone, the audio quality drops a lot. Now, what that means is that if I drop a microphone onto each table and I start listening, I'm going to hear your conversations and it's going to be very interesting. But if I get out of this building and I take the same microphones and I put them in the parking lot, we're not going to hear very much. Now, if everyone got up and a huge thunderous round of applause for Rima at the end of this, which I'm expecting, then even in the parking lot, you would know what had happened. But that's kind of the limit of your resolution. And when you're outside of the skull, that's really what you're dealing with. If you're in a blood vessel or if you're on the surface of the brain, but you're not close to the neurons, it's like being in the hallway. You can maybe pick up on more subtle trends of what's going on in the room, but you just don't have the voices.